Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on route import and control. Let's start our part 8.
Alright, so let's jump back to router tree. So first we are going to configure a route policy, and I call it a RIP underscore to OSPF. Okay, that will be on the node D9 node 10. Okay, so always refer back to your table if I match a tag of 100. Okay, then I'm going to do a route policy RIP underscore to OSPF. So this time I'm going to do a permit node 20. So for the 20 I'm going to apply a tag of 200. Okay, let me show you. That's my policy. That will be on the RIP to OSPF. Okay, so I have a net 10 which is to deny the tag of 100, and I have a node 20 who apply a tag of 200. Alright, so we have not complete yet, so let's configure another policy. Route policy this time will be OSPF to RIP. Okay, deny node 10 if I match a tag of 300, and route policy OSPF to RIP permit node 20, and I'm going to apply a tag of 400. Okay, so when I do a display route policy, so I have two policy here, RIP to OSPF, okay, with a node of 10 and 20, and OSPF to RIP with a node of 10 and 20. Right, so once we have configured our policy, we are going to do a import route with the policy. So firstly, under the OSPF, I'm going to say that import route RIP using the route policy RIP to OSPF. Okay, there you go. So then we go into the RIP. When we do an import route, before this, let me show you here. You can see that we import route without any policy. This time we are going to import route OSPF route policy. This is OSPF to RIP. There you go. Alright, so we have done it on R3. We are going to do the same thing to R4. So on R4, do the same thing. Route policy RIP to OSPF. Okay, we are going to deny node 10 if I match a tag of 400. Okay, then I'm going to do a RIP to OSPF. This time I'm going to permit node 20, apply a tag of 300. Okay, so this is done. Display route policy. Okay, so I have 400 that is being denied, 300 that is being applied. Next, I'm going to do an OSPF to RIP. Route policy OSPF to RIP deny node 10. Okay, so there's a space here. Right, so I'm going to match a tag of 200, and I'm going to permit node 20, and apply a tag of 100. There you go. So under the OSPF, I'm going to apply a policy. Alright, so when import my route, import OSPF, import route RIP, I'm going to use a route policy called RIP to OSPF. Then I go to the RIP, import route OSPF, route policy. I'm going to use OSPF to RIP. Okay, so when I do a display route policy OSPF to RIP, as you can see that there is a match here that is being applied. And if I'm going to do a route policy based on the RIP to OSPF, you can see that I also have a match here. Okay, so if I do a display IP routing table, let's say I'm going to do a Werbrus. Okay, so as you can see that I have a tag. Alright, so that will be on the 200 that is being tagged by the R4. That the tag will be on the R3. Okay, so I'm actually refer to this table when I'm actually configure my configuration. So with this, we have effectively prevent the loop inside this network environment where we do a mutual import. Right, let's look into the requirement here. So deploy R3 and R4 in OSPF area, summarize 10.0x0/24 into 10.0.0.0/16. So R3 and R4 is an ASBR, alright, and since this is an ASBR, we are going to run under the OSPF process ASBR summary. Alright, and the question requires us to use a 10.0.0 with a subnet mask of 255.255.0.0. Alright, so we are going to configure this into both the router 3 and router 4. Now what will be the effect over here is, now since that both the router 3 and router 4 do a mutual import, now when I create the summary from the OSPF, what will happen over here is all the detail route that's sent to R4, which is 10.0.0.0, 10 and 20, will be summarized as 10.0.0.0/16, and it will be advertised to R2. R2 will advertise to R3. Now R3 receive 10.0.0.0/16 and is import back into RIP. Now the first problem here is R5 will receive the detail route plus a summary route. Now on top of that, we will also have a looping. Now assuming that R2 now going to do a ping. Now when it's going to ping something that is not available, let's say I'm going to ping to 10.0.9.9. Now assuming that I'm going to go to R3, and because R3 have the summary route and this route is not inside the detail, it's going to say that, oh, in fact R4 have the route to 10.0.0. Let me send to R4. Now R4 in return receive the summary route from R3 and it check. In fact, it will actually go back to R3. So a looping will happen between R3 and R4. Alright, so let's look into the effect and how to solve this. Okay, so let's just jump back to router 3 and we are going to configure the ASBR summary. So let me go back into the OSPF and our route is still there. Alright, our import route is still there, and we are going to do an ASBR summary using 10.0.0, 255.255.0.0. So I'm in router 3. Okay, so I have done the summary, and when I go to router 2, display IP route protocol OSPF, I should be able to see the /16. There you go. Alright, so it's advertised by router 3. And if I go to router 4, I should receive the route as well. Okay, there you go. Okay, so that will be on the 10.00/16, and I will send to my next hop 24.112, which is here. Now, interestingly, if I go to router 5, when I do a display IP route, as you can see from here, I will also receive the 10 network. Okay, this time I receive it from 4.5, which is from router 4, so 45114. The reason is because that R3 doing the ASBR summary. So this is the first issue. R5 receive a summary route. Now if I'm going to go back into R4 and I'm going to do a mutual summary route and see what will happen. So OSPF ASBR summary 10.0.0.0 255.255.0.0. Okay, so now I have a mutual summary. Now R5 will still receive the summary route, okay, which is the /16, and I'm going to show you from R2 perspective. All right, R2 receive the /16 from both sides. Now assuming that now I'm going to do a trace. Okay, let's say I'm going to ping to an unknown host 10.0.0. You notice that over here it is actually looping and is actually stopped. Alright, so I ping to an unknown IP address. So first it's actually going to the 23.113, that's the router 3, then it go to 35, okay, then it went back to 24, okay, that is the 24.112, then it go into 23.113, then go into 45.114. So it go from router 3 to router 4, router 2, router 3, then router 4, router 2, router 4, and then it go into router 4. So we have a loop here. Now because of the summarization cause the network to have a loop. So now we are going to look into the solving of this problem.
Thanks for watching. Please do not forget to subscribe to our channel.